Once you've finished making your photovoltaic module, it should look something like this. There's our 10 cells, all connected in series, and the two contacts there, the positive and the negative contacts at the top of the panel. So these are connected to test leads, and next to the panel we've got a pyranometer, which measures the level of light incident on the panel. And over here we have a test lamp. This is just a basic halogen work light. Now it doesn't give a very uniform light level across that panel. So in the center of the panel, I was just measuring a moment ago, about 1,300 watts per meter squared. And in the corners it was getting around about 500, 600 watts per meter squared. Now on a bright sunny day we'd have an irradiance level of 1,000 watts per meter squared. Sometimes it's referred to as 1 sun. So in the middle of our panel we're getting higher than that, and on the edges we're getting quite a bit lower than that, a bit more like a hazy day, 600 watts per meter squared. Now I've positioned that pyranometer to be representative of the lowest levels of light that are incident on the panel, and that will determine the current that the panel gives us. So we've got test leads coming out the back of it, and the lead obviously for the pyranometer. This reaches round to our IV curve tracing equipment. This measures the voltage that comes out of the pyranometer, and that gives us the irradiance level, and it also measures voltage and current output from the PV module that we've connected to it, and it steps through a bunch of different load conditions, so lots of different resistances. So it tests the panel at every resistance condition, all the way from the short circuit condition, which is the maximum current condition and a zero voltage condition, all the way through to the open circuit voltage condition, which is the maximum voltage and a zero current. And so it will plot a curve for us of all the conditions between those 2 points. So I shall just put the camera back onto the tripod and take a measurement just to show you. Okay, so the first thing to do is to switch on the tracer. You can't see that because it's off the screen. And to open up the software to run the tracer. The tracer's got no controls itself, it's all controlled from the computer. So it's a software called IVPC3. So I'll open that up. And we'll go to a new worksheet. There we go. We can hit the button that says new curve, and this gets the tracer ready. It pre-charges various capacitors and other bits of equipment that are inside it. So that's now ready to take our curve. I'm just going to set this to, it is an option of high current or low current. So this device can actually measure a very large PV array with like 100 amps and 1,000 volts. Obviously we're quite a lot lower than that. We're aiming for 5 volts and 1 amp or 0.8 amps or something like that. So I'm selecting the low range to make sure that it's set up correctly to measure what we want. I'm going to switch on the power for the lamp. Very bright. Camera doesn't really like that very much, I'm afraid. So we'll see on the screen here, I don't know if you can see this very well on the video, but there's a reading of the irradiance level just here. That's actually reading 800 at the moment. Which is a little bit higher than I measured just before, so I'm going to move that. It was giving me about 600 previously. Okay, but you'll need to measure the irradiance all across the panel, so irradiance level on each cell, just to make sure, and then position this pyranometer to measure a level that's similar to the minimum level anywhere incident on the cells. And that will determine the irradiance level incident on any cell determines what current that cell can produce, and the panel overall will produce a current which is equivalent to the lowest irradiance on that panel, because the cells are connected in series. So we simply hit the take curve button, and this sweeps through now all the resistances from 0 to infinity, and it gives us a curve. Now the curve has a wobbly nature to it there. Now that is actually, we think, a function of the university's mains power supply, which is an oscillation that comes through the lamp and is then picked up by the cells and and affects our measurement. Now, when we use the solar simulator, the large simulator in the lab, or if we do measurements outside, you don't see this waviness. It's a bit annoying that it's there, but we can't really get rid of it. So, but just to explain what this curve is showing us, the open circuit voltage condition is here. So this is giving us, our panel is giving us 5.4 volts maximum open circuit condition, and the short circuit condition, it's giving us 0.52 amps, and that's for this irradiance level. Now the irradiance level at the moment it's saying is about 800 watts per meter squared. If I move it around the panel, that will change, as I mentioned before, because it's not a very uniform irradiance. So that's 500 there, I think. So this is our curve anyway. So the operating point for the panel in reality will hopefully be somewhere around about here. Now this is what's known as the maximum power point. So it's part way between the short circuit condition, which is basically 0 volts but maximum current, and the open circuit condition, which is maximum voltage but 0 current. So we don't want any zero anything, because power is current times voltage. We want the maximum power out of this thing we can get. Handily, the software tells you what the maximum power is. It comes in at 2 watts for this particular irradiance level that we're exposed to, and that 2 watts corresponds to an operating voltage somewhere around this corner, this shoulder on the graph. So it'll be somewhere around about 4 volts, just looking at it, and about 0.5 amps. Again, the software is quite good at giving you summary information. It gives you the open circuit voltage, which I just said there was 5.4. It gives you the short circuit current, which is there, and it also gives you the maximum power, as I said, 2 watts, but that maximum power relates to a certain voltage and a certain current operating point on this graph, and it handily tells us 3.961 volts and 0.504 amps. So it's on this corner here, and that is pretty much it. Thanks.